Good morning, can you hear me? Good morning. Can you hear me? Please send me a message. Hi. Okay. Today we start very important session. Most probably today discussion will be more than one structured essay marks, right? You can collect within today discussion. You can collect 7, 10, 8 to 10 marks in full paper, entire exam. You can collect 8, approximate 10 marks. Okay, I hope to discuss starting from very basic practicals and heat, especially heat practicals today. Heat practicals mean in heat lesson we have 4 main practicals. The first one is uh, determine the heat capacity. Sorry, specific heat capacity. Determine the specific heat capacity using mixture method. The next one is determine the specific latent heat of melting. The next one is determine the specific latent heat of vaporization. And we have some mixture method, another simple practical as well. Right? We have 4 main practicals in heat lesson, and we have very basic practicals from measurement lesson and fluid mechanism YouTube monometer practical, U shape monometer practical. Last day also, yesterday also we discussed some part of questions. Hari in final part we have some mechanical properties of matter practical as well. Okay, that's a today schedule. And finally, we have some ICT practicals. I hope to complete ICT practicals in evening session. In evening, we have time to discuss ICT complete part, right? ICT practical, Excel, Word, and how to each function working and what are the short keys, everything. Okay, let's start with first practical. Our first practical is, yeah, I have sent the practical guide. Can you open this? So not this one. Oh, give me 1 minute. Okay, sorry. Board, the file is missing. Okay, now it is there. Yeah, this one. Okay, our first practical, vernier caliper. How to use vernier caliper? Okay, the vernier caliper, it's very simple practical. Try to complete and try to revise, right? Making questions in the pulwang. The usage of vernier caliper. What are the finding volume of a block of wood and finding they are the objectives. Finding the volume of material of PVC tube. Okay, they are the experimental purpose. Find the volume of material of solid sphere. Okay, ඒ වෙලක් නෑ අපිට. මෙන්න මේ ටිකයි දැනගන්න ඕන. The vernier caliper. Okay, this is a they are the main parts of the vernier caliper, right? This is a vernier caliper. I think you can remember what are the parts of vernier caliper, right? Okay, let's revise what are the parts. Okay, what is the name of these jaws? They are internal jaws. Internal jaws. They are the internal jaws and external jaws. They are external jaws, and this is the vernier caliper, the vernier caliper, the vernier scale. Sorry, vernier scale, and the main scale. Main scale. What is the meaning of this? It is pin or depth measuring pin or depth measuring strip. Make it කියනවා depth measuring strip කියලා. Depth measuring strip. Depth measuring strip. Depth measuring strip. Pin or depth measuring strip. Depth measuring strip. Strip. Right? They are the main parts of vernier caliper. Internal jaws, external jaws, vernier scale and main scale, and depth measuring strip, and this all moving parts. මෙන්න මේ ඔක්කොම moving parts එකට අපි කියන මෙන්න මේ moving parts of the vernier caliper. The single name is sliding jaw. See, the sliding jaw is a single, the common name of all moving parts. All moving parts, and the entire fixed components, fixed parts we called as fixed jaws. මේ part එකට කියන්නේ fixed jaws, right? මතකයි? හරි. Okay, the next thing is how to calculate the least count of this type vernier caliper. How to calculate the least count? What's the meaning of least count any measuring instrument? The minimum measurement we can accurately obtain by any instrument. The minimum measurement, the smallest measurement accurately can be obtained by any instruments. Okay, do you remember what is the equation? The least count of vernier caliper. Matakai, Joel? The least count of vernier caliper. What's the equation? The least count equal. The least count of vernier caliper equal MSD minus VSD. MSD minus VSD. MSD minus VSD. Think the basic principle of vernier caliper, 9 millimeter on main scale. Within main scale 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 mean 1 centimeter or 10 millimeter. Right? Think 9 millimeter on main scale divided into 10 identical parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? How to get the least count of this type instruments? හරි කොහොමද බලන්න least count එක ගන්න? I think you can remember that. මේව මතක් කරගන්න ඕන. They are the practicals. Not this is measurement lesson practicals, right? අපි lesson by lesson complete කරගෙන යන්න තියෙන්නේ. Okay, let's start from very basic level. Don't skip today class. කවුරු හරි මේ leave වුණොත් quickly join with our YouTube video. It is very important. Heat lesson practicals, especially very, very important, right? In the heat lesson. Give me a second. Okay. Okay. How to get the least count of this type instrument? 9 millimeter on main scale divided into 10 identical parts on vernier scale. Okay, this is a main scale. Main scale, the above scale, the longest. Normally, what is the length of main scale? Kabir, what is the total length of main scale? What is the maximum value of vernier caliper we can obtain? අපිට ගන්න පුළුවන් මෙන්න මේකේ තියෙන මේ what's the final value? It is very good, 15 centimeter. The මම මේක ඕනම් තව අඳින්නම්. Okay, this is the main scale, right? This is the main scale. 0, 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. 10 mean 10 millimeter, 1 centimeter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 mean 20 millimeter. That means 2 centimeter. It is continue up to 150 millimeter. That means 15 centimeter, right? 15 centimeter. The common vernier caliper, how about the scale of common vernier caliper? This 9 millimeter on main scale, මෙන්න මේ part එක 9 millimeter on main scale, මෙන්න මේ part එක 9 millimeter on main scale divide into 10 identical parts. මෙන්න මේ gap එක divide into 10 identical parts. 10 identical parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. Right? I got. This type instrument, how to get the least count of this type instrument? In the lesson we already discussed. The main instrument it is 9 millimeter divided into 10 identical parts. Right? This is a vernier scale, the scale position and principle, scale principle. Right? එතකොට කොහොමද ගන්න? MSD minus VSD. What's the meaning of MSD? Main scale division. Main scale division mean මෙන්න මේ part එකක්. One part on main scale. The gap between two parts on main scale, it is 1 centimeter. Sorry, 1 millimeter. 1 millimeter minus VSD mean vernier scale division. Vernier scale division එකක් කියන්නේ, now you can see 9 millimeter gap divided into 10 identical parts. 9 millimeter gap divided into 10 identical parts. Right? Then what is a VSD? What's the VSD? Very good. Then 9 millimeter divided into 10. Then we can get one vernier scale segment. One vernier scale, එක part එක length එක එනවා. හරි. That's the method. Then we can get 1 millimeter minus 9 over 10 means 0.9 millimeter. Then we can get 0.1 millimeter is normal regular type. Regular type. 9 millimeter divided into 10 vernier caliper. The least count is 0.1 millimeter. This type instrument, the least count is 0.1 millimeter. 0.1 millimeter, right? අපි ගමු short method එකක්. What's the short method we can get the least count of vernier caliper? හරි, මොකද short method එක? Yeah, the short method is 1 divided by vernier scale parts. Then make a vernier scale parts 10. Then it is 0.1. Only use this method for MCQ questions. Don't use, if it is structured or essay question, you have to use this common equation. For short method, it's okay for MCQ questions. MCQ වලට no problem. Are you good? වැඩ තේරුණා? Tanya? මේ බලන්න, different type of instrument, different type, 49 millimeter on main scale. It is not regular type. 49 millimeter on main scale divided into 50 identical parts on vernier scale. 49ක් 50කට බෙදලා තියෙනවා. 49 on main scale divided into 50 identical parts. Right? Then how to get the least count? In short method, 1/50. 1/50. 0.02 millimeter. Are you clear? Okay. 1/50. Okay. I need your response. Hari. Okay, the least count is done. Okay, if you know the least count, let's see how to read a measurement using vernier caliper. How to get the measurement using vernier caliper. And they are the purpose, this is a purpose of external jaws, to get external diameter or thickness of any substance, right? This is a purpose of internal jaw. This is an internal jaw to get internal diameter. And the depth measuring strip we can use to measure the depth of any substance, depth of any hole. Yeah, this is the depth of any hole. Hurry. Now you should let's move into, give me a second, let me open the vernier caliper. Okay. Okay. This is a vernier caliper. You can see 9 millimeter on main scale divided into 10 identical parts by main vernier scale, right? Median 9 millimeter. 9 millimeter up to this point it is 9 millimeter on main scale divided into 10 identical parts. Okay, they are the main parts of vernier caliper. They are the internal jaws, median internal jaws, external jaws, and main scale, vernier scale, and the depth measuring strip. Okay, now let's see how to read a measurement using vernier caliper. Okay, let's take this type measurement. Okay, how to read a measurement? how to read this measurement. Okay, what's your first step? What's your first step? Read the main scale reading. Main scale reading. What's the main scale reading? 0, 1, 2, 3, 4. 4 millimeter is the main scale reading. Get me as main scale reading the previous value before vernier scale 0. Right? මෙන්න මෙතන 0 තියෙන්නේ. එයාට කලින් එක තමයි main scale එකේ ගන්න. Right? 0, 1, 2, 3, 4. Before main scale 5, the vernier scale 0 is there, right? Therefore, 4 millimeter is the main scale reading. Then get the second step, get coincide number. Coincide number from vernier scale. 0, 1, 2, 3, 4 is coincide. The coincide one is 4. The next one is 4 multiplied by least count. It is 10 vernier scale parts mean its least count always 0.1. Then 4 multiplied by 0.1, it is 0.4. 4 plus 0.5, main scale value plus vernier scale value. Main scale value 4, vernier scale value 0.4. 4 plus 0.4, 4.4 millimeter. Are you clear? Hari, මේවා අපි ඇති වෙන්න කරා මම just revising. Hari, quickly can you send me this value? Quickly send this reading. Hari, don't take time. We have a lot of practicals today. They are very simple practicals. That's why I rapidly complete this. Okay, what is this reading? Quickly. Mantada. What is this reading? Anyone? Hamauda. There are only two others. It is good. All are correct. The main scale value, it is 10 millimeter, 11, 12, 13. The coincide value 3, then 13.3 millimeter. Good. 13.3 millimeter. The next thing is, what is the meaning of the least zero error of the vernier caliper? Okay, what's the meaning of zero error? The vernier caliper zero error mainly two types. The first one is positive zero error and the next one negative zero error. Okay, positive zero error mean in the contact stage of external jaws. Okay, this is a positive zero error. The positive zero error coming due to something apply on the jaws, due to something apply or corrosion. Okay, this is a positive zero error. In the contact, while contact these external jaws, what happened? The main vernier scale 0 shift right side than the main scale, right? The main vernier scale 0 shift right side than the main scale, right? Yeah, product shift in a right side. Okay, then how to get the positive zero error? It is very simple. Just get coincide value and multiply by least count. Positive zero error, just get the coincide value and multiply by least count. In this stage, if it is, this is the zero error, positive zero error, the positive zero error coincide value 3, then 3 into 0.1, it is 0.3, right? 0.3 millimeter. and this positive zero error coming due to something apply. Monohari apply when nisatama positive zero error again, right? Or corrosion. Therefore, how to correct this reading after measure some reading? How to correct this? We have to subtract. If you got this type previous reading, what was the previous reading? 13.3 millimeter. Then 13.3 millimeter. If you got instrument with positive zero error, we have to subtract this. Then 13 millimeter is the correct reading. We have to subtract 0.3 millimeter. Clear? Mami මේවා ඉක්මනට කරන්න අපි වැදගත් practicals වලට යන්න ඕනේ. Right? We have to move quickly. Most important practicals, heat and first lesson practicals. Hari. Any doubt you can ask me. I'll revise and go further. Hari. Okay, the next thing is, what's the negative zero error? The negative zero error mean due to wearing of these jaws, what happened in the contact stage, the vernier scale 0 shift left side than the main scale 0. Vernier scale 0 shift left side than the main scale 0. The reason is wearing off of jaws, especially external jaw wearing off, given answer, right? Removing smooth layers from external jaws. Due to that, the vernier scale 0 shift left side than the main scale 0. Right? Okay, that we call negative zero error. Then how to get the negative zero error? That's the point you have to be very careful. In negative zero error, you have to get coincide part and subtract from total vernier scale part. Meaning then coincide part is 8. Coincide part 8. Then you have to get 10 minus 8. The total vernier scale part 10 minus 8, it is 2. 2 multiplied by vernier least count. Then it is 0.2 negative zero error. 0.2 negative zero error. You can get any measurement using this instrument. Now think previous measurement 13.3 millimeter. Then how to get the correct reading? 13.3 millimeter add to the 0.2 millimeter. Because in wearing off, due to wearing off, we have to, for correct reading, we have to add negative zero error into correct to get correct reading. Then 13.5 millimeter is the correct reading. Hari. Okay, this is the summary. Okay, any doubt from vernier caliper? Any doubt from vernier caliper? Okay, in our practical tooth, it is given a same thing given with different experiments, different practicals. Measure the length and breadth and height of wooden block. Okay. Find the volume of material of PVC tube. Okay, make the එක measurements ගන්න විදිය, right? Okay, this is a PVC tube. Get the external diameter by external jaws and internal diameter by internal jaws. Make it the least count of vernier caliper, it is 0.1. If you feel this, it is 0.1 millimeter. 0.1 millimeter. The zero error of vernier caliper, think there is no zero error. Okay. May balanda. This is a method, measurements of wooden block. The length, width and height. If you got the length, width and height of a wooden block, you can get the volume, right? Volume meකට මෙන්න මෙහෙම මේ අපි දැන් මේක actually කරලා බලන්න ඕනේ. දැන් අපි measurements ගද්දි we have to get the recommendation is get 3 measurements to get more accurate measurements. මේවා තමයි points practicals වලදී අල්ල ගන්න ඕනේ. Okay, in the recommendation of taking measurement of any instrument, get 3 measurements. Then length එක අපි 3ක් ගන්න ඕනේ 3 times on 3 points. That මේක නම් wooden block එක. Think this is a wooden block. We have to get this point, middle region and then may length එක. May හරි එකක් ගන්නවා length එක. first length, second length, and third length, right? The length was 8.3 millimeter, 8.2 millimeter, 8.3 millimeter, right? That was a 3 measurements. Then to get more accurate reading, we have to get the mean value. That's very simple. That's I already explained. මේ තුනම add කරලා we have to divide by 3. එතකොට add කරලා බලන්න. එතකොට you can get mean value. That's a method to get more accurate reading in vernier caliper or any measuring instrument reading experiments. Clear? Clear? Make it එහෙමයි. Right? Make it එහෙමයි. This is positive, negative, zero error. I already explained. Hari. Any doubt? Do you have any doubt? Okay, I hope to complete one practical within 20 minutes. That's our target. If not, we can't complete today everything. All practicals. Now 20 minutes done. First practical is done. Do you have any doubt? It is very simple practical, right? Give me a second. Okay, sir. Okay. Can you hear me now? Is it clear, right? Hari. No doubts. Good. Hari. Let's move into our second instrument, micrometer screw gauge. Okay. First, let's move into identify parts of micrometer screw gauge. This is a micrometer screw gauge. This is a micrometer screw gauge. What are the main parts of micrometer screw gauge? Do you remember? Okay, what is this one? What is this one? This solid part? It is. I want to answer. දැන් මේ වෙලාවේ ඔක්කොම රිවයිස් කරගන්න. That's the purpose of today's session. You have to revise everything. දැන් මේ now we hope to spend 4 hours from your study time for this session. Right? It's very important time. Don't waste this time. Within this session you have to maximum revise. Again, all more than your self studies, you have to work within this session. That's the advantage. If not, better to go and do your self study, right? It's time waste actually. Insa nikam balan inpa everything try to revise maximum. This is your golden time wasting, right? Hari, what's the name? What's the name of this part? Anvil, right? Good, anvil. And spindle. Spindle. This, the next solid is spindle. This one, spindle. Spindle. Make parts තියෙනවා. Okay. Anvil, spindle. Anvil, spindle. And this is thimble. This one, thimble. The rough solid rod. Solid cylinder. This is thimble, and this small part is thimble head. Oh, there is another name. It is ratchet. It is ratchet. 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 Right? Ratchet. Okay. The next thing, the main scale of the linear scale or main scale of the micrometer screw gauge. The main scale or linear scale of micrometer screw gauge, it is calibrated on a sleeve, iron sleeve, like this. The main scale is calibrated on an iron sleeve, like this. It is calibrated on iron sleeve. Okay, this is an iron cylinder, right? Metal cylinder, and there is a middle axis. This is a linear scale middle axis, right? Linear scale middle axis. Linear scale middle axis, and it is 0, 0, 1, 2, 3, 4, and each 1 millimeter divided into 0.5 like this. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. It's marked by 5 by 5. 5 by 5 තමයි mark කරලා තියෙන්නේ. Is there any lagging in our video? Yo, is there any lagging? No lagging. Small lagging, no? There is a small lagging, but is it disturbed? Clear. Okay. Wait, let me check. Wait, let me check. No, okay. Hi. Okay. This is the main scale or linear scale. It's calibrated 0.5 to 0.5. This is the way, right? 0, 0.51, 1.52, 2.53, 3.54, 4.55, and it passes 6, 5.56, 6.57. Okay, what is the total length of linear scale on micrometer screw gauge? What's the total length? What's the total length? Guys, this. What's the total length, Tanya? What's the total length? What's the total length of this? Quickly. Lini, what's the total length of the main scale or linear scale of micrometer screw gauge? No, Joel. Quickly. Amina, what's the total length? What's the total length? Kabir? Fatima, what's the total length? What's the total length of this? Yeah, very good. It's 25 millimeter, 2.5 centimeter, 2.5 centimeter or 25 millimeter, right? 25 millimeter. Continue. Joel, not 10, 25, right? 25 and I can't the length of main scale, it is continue up to 25 millimeter. And there is a the main thing is this micrometer screw gauge consists of circular scale. Circular scale, it consists of 50 identical parts. Normal regular instrument, 50 identical parts. These 50 parts increase into this direction, 5 and 0. It was මෙහෙම ගිහින් 5, 10, 15 and continue up to this is 45, 44. මෙහෙට තමයි වැඩි වෙන්නේ. Always increasing to upward direction, right? Always increasing to upward side. Upward direction. Always increasing to upward direction, right? මෙහෙම බැලුවම the value is increasing to upward direction, right? 10, 15, it's increasing to upward direction. Remember that. Okay, normally it has 50 divisions, 50 divisions. Okay, the next thing is there is special words in micrometer screw gauge, that is there is a special word, it is pitch. pitch, or screw gap. Screw gap. What's the meaning of screw gap? While rotating one revolution of circular scale along linear scale moving distance. The circular scale moving distance along linear scale within one complete revolution. Within one complete revolution, make a rotation rotate with the, it has a screw principle. Screw it is the circular scale is moving to the linear scale within one complete revolution. The moving distance of the circular scale we called as the screw gap or pitch. Right? It is pitch or screw gap. What's the meaning of pitch or screw gap? The circular scale moving distance along linear scale within one complete revolution of circular scale. It is pitch. Normally this regular instrument it is 0.5 millimeter. When gap this point, this gap, very small gap, it is traveling within one complete revolution. Within one complete revolution. Hari, good. Okay, the next thing, how to get the least count of micrometer screw gauge? How to get the least count of micrometer screw gauge? The least count equals screw gap divide by number of circular scale parts. Number of circular scale parts. Screw gap divide by number of circular scale parts. Okay, how to get the least count? Least count instrument. How to get the least count of this type instruments? How to get the least count of this type instruments? The screw gap is 0.5. I told 0.5, and number of circular scale parts. How many number of circular scale parts? Joel, how many number of circular scale parts? It is 50. Good. Then 0.5 over 50 it is 0.01 millimeter is the regular and commonly used micrometer screw gauge. The least count. The least count is 0.01. Okay, let's move into next part. How to get the reading using micrometer screw gauge. How to get a reading using micrometer screw gauge. I'll share the instrument quickly. Okay. Can you see my screen? Can you see my screen? Sharon? Hi. Okay. They are the main parts of what are the parts of micrometer screw gauge? Main parts of micrometer screw gauge. What are the main parts? It is the anvil and spindle. This part is a spindle. Main part is a spindle. This part is a spindle, and this is the linear scale or main scale. It's a linear one. This is a linear scale. This is a circular scale, thimble and thimble head or ratchet, and this one is the frame. Frame, right? All components connected to the instrument by this frame, right? All the components connected to the instrument by this frame. Okay, the next thing. Okay, this is the nature of linear scale, 0, 0.5, 1, 1.5. It is the calibration way, and I told the circular scale values increasing to upward, 10, 15, 20, 25. Okay, you think, Okay, then let's see how to get the reading of micrometer screw gauge. How to get a reading of micrometer screw gauge quickly. Okay, can you read this type reading? Okay, what's the first method? It is same as vernier caliper. First get the linear scale or main scale value. 0, 1, 2, 3, 3.5 millimeter is the linear scale reading. 3.5 millimeter. Then get the coincide part with linear scale middle axis, it is 35. Then 35 multiplied by 0.01, it is least count. It is 0.35. Then 3.5 is the linear scale value, 3.5 plus 0.35. 3.5 plus 0.35, then it is 3.85, right? 3.85 is the reading. Are you clear? Dihini? Harnir? Okay, quickly send me this reading. This reading. Manda. What's the reading? Very good. 4.47, great. 4.47 millimeter, great. Okay, now you can read any reading of micrometer screw gauge. Abhyang, the least zero error of micrometer screw gauge. Okay, same as vernier caliper, micrometer screw gauge also. There are two main types of zero error: positive zero error and negative zero error. Positive zero error means the same reason. Positive zero error come from due to something apply or corrosion of anvil and spindle, anvil or spindle or both, right? Anvil or spindle or both. The reason is corrosion or something apply. Okay, the positive zero, in the positive zero error, what happened due to something apply? Due to something apply, in zeroing stage, the zeroing stage means we have to maximum tied by thimble head or ratchet, right? Fully tied by thimble head like this. Okay, fully tied by thimble head. Then what happened? Then what happened? The zero and linear scale middle axis is not coincide. That is the meaning of zero error of micrometer screw gauge, right? This is positive zero error. How to identify positive zero error? How to identify positive zero error? Due to something apply between anvil and spindle, circular scale zero stopping before it to the zero. මෙන්න මෙයා හරිනම් නතර වෙන්න ඕනේ මෙතනට ගිහින්. If there is no zero error, remember, if there is no zero error, this is the correct position without zero error, but due to something apply, due to something apply in the zeroing stage, yeah, this is the position. This circular scale zero stop before it to the zero, right? කලින් අතර වෙනවා before it to the circular scale zero. Circular scale zero stopping before it to the middle axis. Before it to the middle axis. Okay, how to get the positive zero error? Then ඔයාලට අඳුර ගන්න පුළුවන්. It is the coincide part 5. Positive zero error, very simple. 5 multiplied by least count, it is 0.05. And for accuration, you have to subtract, same as vernier caliper. Hurry. In what's the meaning of negative zero error? As a result of wearing off anvil or spindle or both, wearing off, what happened? Wearing off unam mokada wenne. In the zeroing stage, this is the state. Circular scale 0 passing away from the Vadipura, additionally rotate and passing away from the circular linear scale middle axis. Right? Vadipura rotate, additional rotating. That is a negative zero error. The negative zero error most important, same as vernier caliper negative zero error. Then how to get the negative zero error? Just get the coincide value, it is 44. 44 is the negative coincide value. Subtract from total circular scale parts. The total circular scale parts 50. 50 minus 45. 50 minus 44. It is 6. 6 multiplied by least count. Then 0.06 millimeter least count is the, sorry, negative zero error is 0.06 millimeter. 0.06 millimeter. Okay, clear? Any doubt? Amina? Hari. This first and second practical I rapidly completed because that we already discussed in our theory classes. These practicals we already discussed, I only revised, right? Okay. Tanya? Okay. Up to now. Hi. Okay, this is positive and negative zero error explanation. I already done it. Hi. Let's move into the most important forces lesson experiment. Forces lesson experiment. The forces lesson experiment. May in micrometer screw gauge also, if you want more accurate, more reliable measurement, we can get several times. Up to 3 times, 4 times are again, we can get the average value, mean value. Right? That one also recommended method in practical. Okay, now 9:30, 2 practicals done. Okay, this is our third practical. Habir, are you clear up to now? Any doubt up to now? You can ask me. Then. It's easy. I don't know you understood or not. Fatima? Dehini? The first lesson practicals, this is parallelogram theorem. 2016, as I remember, 2016, as I remember, there was full structured essay question from parallelograms theorem. The verification of the law of parallelogram of force and using the determination of mass of a body. This that we called as parallelograms theorem practical. Parallelograms theorem practical. Sorry. The most important practical. The first thing, let's see what are the requirements. Requirements for this complete practical. Okay, they are the materials and apparatus required. The first thing is we need make a what are the requirements? You can work on after today practical session. I will give you what are the practical past paper questions. Then you can try these questions. There was past paper question. What are the apparatus? What are the materials required to parallelogram theorem, law of parallelogram theorem practical? Okay. The first one is parallelogram force apparatus. Make a kit parallelogram force apparatus kit it's contain a board and pulleys and string and two known mass is there, right? May pack lab and the unknown mass is required. Unknown mass mean that's the mass we can find the weight and mass using this method. And three known loads, known masses is required. Especially short plane mirror strip is required. Plane mirror like this. Mirror plane like rectangle. A meter ruler or half meter ruler is required, and pins required. Drawing pins and A4 right paper and make it A3 okay, right? A3 paper also okay. And triple beam balance required to measure the mass of measure the known masses. Now, how to do this practice? Okay, do you remember? Then first you need to understand what's the purpose of doing this practical. Do you remember? Do you remember the resultant force topic in lesson number 5, force lesson? The resultant force, we can find the resultant force of theory, right? We can get the resultant force. Two forces act along same direction, A plus B or P or Q, P and Q. How to get the resultant force? P plus Q, P plus Q, P plus Q. The resultant force direction is equal to the force direction, forces applied direction. Two forces exerted on opposite directions, P and Q. How to get the resultant force? The resultant force equal greater value, P minus Q. P minus Q, the P direction is a greater force direction is a resultant force direction. Two forces acting along perpendicular directions. Then this is the resultant force P and Q. Okay, how to get the resultant force? Using Pythagoras theorem. R equal P squared plus Q squared square root. It is Pythagoras theorem. Do you remember in final part I explained two forces acting along different angles, theta degree angles, P and Q. Two forces acting along different angles. That means less than 90-degree angle. This angle, if it is 90-degree angle, it is perpendicular to each other. Then you can use Pythagoras theorem. P square plus Q square is square root. Right? But to get the resultant force of less than 90-degree angles, what I told, I gave an equation, right? The method is very important, right? ඒක නිසා පොඩ්ඩක්වත් මිස් නොකර අහගන්න. ආයි මේව කොහෙවත් කරගන්න වෙන්නේ නැහැ. Dihini, what's the equation I gave you to get this type resultant force? මෙන්න මෙයා හොයන්න R හොයන්න. To find R. What's the equation I gave? What's the equation I gave you? Yeah, R equal P squared plus Q squared plus 2PQ cos theta square root. Do you remember? R equal P square plus Q square plus 2PQ cos theta square root. I told, then do you remember this Pythagoras theorem we apply for rectangle. මෙහෙම rectangle එකක් විදියට හැදුවම this diagonal is given the resultant force. This diagonal is given the resultant force. Then P squared plus Q squared square root equal to hypotenuse side length. Right? This is a method. But how to get this type two forces resultant force? Do you remember I told it is taken, it is fine, complete as a parallelogram. If this two force system complete as parallelogram and its diagonal of this parallelogram represent the diagonal of this parallelogram represent the resultant force. Do you remember? Tanya? Fatima? The parallelogram of this, the diagonal of this parallelogram is represent the what? The resultant force of two forces acting along less than 90 degree angle. Clear? Is it okay? Quickly. Okay. Then how to get the resultant force of two forces less than 90 degree angle? R squared P squared plus Q squared P squared plus Q squared plus 2PQ cos theta complete square root, full square root. How to get in practically, how to get this? Complete as a parallelogram and get the length of this diagonal. Diagonal එකේ ඒ කියන්නේ විකර්ණය දිග ගන්න තියෙන diagonal එකේ. Right. Hi. Okay. Now we are going to prove this experimentally, practically prove this theory correct or wrong. හරිද? අපි මේක test කරලා බලන්න යන්න. හරි. For this, the first one, in the first step, හරියටම අහගන්න, right? In the first step, you should this type wooden board. Think this is a wooden board. Get the wooden board like this. It's a rectangle wooden board. Wooden board. And this force apparatus system lab එකේ තියෙනවා. There are 2 points to මේ same axis, මෙතන same line. There are 2 points to fix 2 pulleys. Normally we have to get very low friction pulleys, very smooth pulleys, with very low friction. With very low friction, right? Okay, hari. I connected. Before that, before connect pulleys, we have to connect the paper first. Paper connect කරගෙන ඉන්න ඕන. හරි. මේ තියෙන්නේ white color paper. A3 paper is best for that. හරි. අපි මෙන්න මේ විදිහට paper එක connect කරගමු දැන්. This is a paper. This is a paper, right? This is a paper. This is a paper. Okay, how to connect this paper? You can use drawing pins. Drawing pins. හතරක් ගැහුවම එක connect කරගන්න පුළුවන්, right? You can use drawing pins. Then you can connect 2 pulleys. Smooth pulleys. හප්පි දෙකක්. හරිද? Smooth pulleys. 2 smooth pulleys. right? Now you can select the laboratory contain very light strings. Light string mean very low mass. The weight of the string is neglectable, right? Api mehema you can add string and hanging මෙතන අපි L ගන්නවා to non mass think it is P and it is Q මෙයා Q and P and Q right P and Q P and Q then the center of this string between two pulleys, the center hanging another mass. What happened to this string? This string is coming like this. Like this. Think it is W. Hi. Okay, this is a story. Okay, first clip the white color paper and connect by drawing pins and connect two pulleys and hanging masses, 3 masses like this. These are 4 system. Up to now okay? Okay. I will show you all the steps. Practically karna vidhiya mama pennana danata therunga, right? Okay, what is this? This is a wooden board. This is a paper. Hari Kabir, up to now okay? Sharon? Hari. The next thing is, the next step are the ඊළඟට අපි මොකද කරන්නේ? We have to check the friction force. Friction of the pulleys. I told we have to select very smooth pulleys. Smooth pulleys gone on. If there is any friction, considerable friction on this pulleys, this experiment will be not completed. Experiment coming errors, right? Data coming errors. Then we have to make up we have to give some force on this Q force of any pulley and again release it. If it is again come to the same position, previous position, then we can check, we can confirm there is no any considerable friction. Make mehem poddak adala change the position and release it. If it is again return to the original position, then we can satisfy it is, both pulleys are smooth pulleys. Clear? Okay. First step is set the pulleys and paper and masses and check. Second step, check the friction. How to check the friction of pulleys? Change the position of one mass and release again. If it is returned to original position, that's perfect. Hari. Very hurry. Think now there is no considerable friction. Again return to the original position. Okay, now the setup is done. now you have to get now you have to get the bar. I told we have to get which type mirror. I told we have to get mirror, right? Plain mirror strip. Plain mirror strip like this. මේ වගේ එකක් ගන්න ඕනේ mirror එකක්. Right? Now we have to place this mirror like this. And the reflection you can mark the reflection you can mark on the paper. මෙන්න මෙතන mark කරනවා reflection එක. That means the string reflection mark on the paper. String reflection mark on the paper. Two dots දෙකක් mark කරගන්න. And place this plain mirror on this string and mark 2 points. Points දෙකක් mark කරන්න. Reflection mark on the paper. Reflection mark on the paper. Hi. This string also you can mark 2 points on the paper using mirror. Right? Mirror ke mark karne de mama pennanna. Don't worry. Now understand the third step is fix the setup and check the friction force. The third step ekedi api mokada karanne mark this string positions on the white color paper using plain mirror. Hari. Now the thing is you can remove this pulleys and get out this paper. එළියට ගන්න paper එක. paper එක එළියට ගන්න. මෙන්න මෙහෙම. Now this is the paper. This is a paper. Right? This is a paper. And it's contain this type method test dots. Dots like this. Okay, they are the marks lines. The next thing you can use ruler. The next step, use ruler and mark this all lines. මේ lines mark කරගන්න. යා කරගන්න. Like this. Like this. Like this. Okay. You can draw lines along these points. The next thing, now think you have to select a suitable scale. හරිද? අපි select කරගන්නවා. දැන් හිතන්න if you got 40 kilogram 40 Newton object on this P and Q should be same, right? Think 40 Newton. Think you can select a suitable scale. 1 centimeter represent 10 Newton කියලා. 1 centimeter represent 10 Newton on our scale, right? This is our scale. දැන් මොකද කරන්නේ? To represent 40 Newton, then මෙයාගේ 40 Newton එක represent කරන්න, you can get a compass and draw a mark 4 centimeter on this line. Hari 4 centimeter mark. Then this one also mark 4 centimeter. Now you can complete as a parallelogram. These 2 points complete using compass, complete as parallelogram. මෙන්න මේ විදිහට parallelogram එක complete කරන්න තියෙනවා. Right? I will show you how to complete. Okay. Now you can check this line aligned to this vertex. මෙන්න මෙහෙම මේ line එකට vertex වෙනවද කියලා මෙන්න මේක sorry මෙන්න මෙහෙම බලන්න. Actually in experimentally now my one is not experiment. It has some errors, right? It has some error. If you did this experiment without any error, this line completely come as diagonal of this parallelogram, right? Okay, that's how we can prove the parallelogram theorem. Okay, now if you want to get the result force result force එක ගන්න පුළුවන්. Now you can measure the length of this diagonal. අපි හිතමු එයා 6 centimeter කියලා. 6 centimeter, then the result force equal 1 centimeter represent 10 Newton, then it is 60 Newton. Are you clear? Are you clear? Are you clear? If you want final part again, I can explain. I think up to paper separation, you are clear. Everyone clear? අනිත් ටික තේරුම් නැත්තහම. දෙහිනි? Okay. Yeah. Yeah, Rehlan, up to paper separation, you are clear, right? Separate the paper from the system, from the board. Hi. Hi. Now, then P and Q both masses are known masses, no? Known masses. Then we can select a suitable scale. Think I select 1 centimeter represent 10 Newton. Then to show the 40 Newton, I got 4 centimeter. I got 4 centimeter. Right? 4 centimeter part. And complete as parallelogram. You can use compass for the use make a complete. I'll show you how to complete. Right? Okay, now you can draw this diagonal. If it is coming this diagonal and this line as linear, as a single line, this parallelogram theorem is perfectly correct. If this when the main line and this diagonal is coming as same line on the same linear axis. Right? Okay, if it is correct, you can get the length of this diagonal. Think if it is 6 centimeter, 1 centimeter represents 10 Newton, then 6 centimeter equals 60 Newton. Then the resultant force of P and Q, 40 and 40, resultant force is 60 Newton. 60 Newton is the resultant force. Right? Okay, now I'll show you how to do this. Right? Give me a second.
Parallelogram law of vectors. To find the weight of the given body, use the parallelogram law of vectors. Let's understand the main parts of wave-sense apparatus.
Okay. This is a wooden board, right?
Place a paper on the wooden board.
Okay, they are the steps. Place a
Take
paper.
pins from the box. Firmly fix the paper on the board using pins. Take a thread and pass it over the pulleys and
they are the two pulleys. Two pulleys, and these are light string.
Say 20 grams to both ends. Mark it as P and Q. Another bead attached to a third string is tied to the middle of the first thread and marked as O and S. Hang another 20 grams to both ends.
Okay, they increasing the force until it's coming to the favorable height, into correct height.
With a mirror strip beneath the thread and mark the points of the pencil.
This is the marking process.
The mirror where its image coincides.
Mark on this point and this one.
Do this for the other two threads. Remove the paper from the board by
removing the paper from the board.
Sit on the table. Join the marked points with the pencil and a scale. Assuming a scale of 20 grams, OA is equal to 4 centimeters, OB is equal to 4 centimeters to represent P equals 80 grams weight and Q 80 grams weight respectively. Measure the to represent P equals 80 grams weight and Q 80 grams.
Okay, see there scale P equal 80 gram, then Q equal 80 gram, then 1 centimeter represent 20 gram. They select one axis 4 centimeter, that means 80 gram. The other axis also 4 centimeter, 80 gram.
Respectively. Measure the either sides of point O with the scale.
4 centimeter, that means 80 gram, right? You can select any scale. Then if you select 1 centimeter equal 10 gram, then you have to get 8 centimeters, right? No problem. On scale
measure 4 centimeters.
4 centimeter compass.
Draw an arc from point B. And another arc from point A joining the previous one and mark it as C.
This is a
parallelogram OBC.
Now you can draw the
it is found that OC is equal to 4.3 centimeters.
It is 4.3 centimeter. It was the diagonal length was 4.3 centimeter.
Draw C. It is found that OC
4.3 centimeter, right? 4.3 centimeter mean 1 centimeter 20, 1 centimeter 20 gram, then 4.3 centimeter mean you can find the resultant force R, right? R. Okay. Now okay, Ratna? Okay, this is a parallelogram theorem practical. Okay, Kabir. Up to now, okay. This is experiment. You can ask questions, doubts. Fatima, any doubts? Dihini, are you clear? Rehlan, now okay? Amina? Okay, the other thing, actually, if you did this experiment practically, ඔයාලා board එකේ make කරොත්, most probably this line and ගොඩක් වෙලාවට this line and the diagonal is not coming as a single line, single straight line. සමහර වෙලාවට මෙහෙම එනවා, right? The line is coming like this. It is coming due to experimental errors. If you did this experiment with recommended ways, it is your this line should single line with parallel diagonal, but in practically it's coming practical errors. Okay, what are the reasons for these practical errors? That one also exam question. One of the reasons, the one reason is the if we check several times, the pulleys have some friction. That's the one reason. Pulleys have some friction. That's a one experimental error. Pulleys have some friction force. The other thing, if we neglect the weight of string, the string also contains some weight. String also contains some weight. Right? Due to these errors, sometimes this line is not coming as single line as with diagonal. Right? ඒව තමයි experimental errors. Okay. Experimental errors. Okay, this is the parallelogram theorem complete practical. Okay, let's move now. We got 35 minutes for that. අපි යන් next එකට. Next practical. Okay, that's a very simple one. Determine the mass of body using principle moment of force. That one also force lesson practical. Moment of force practical. Moment of force practical. That we already discussed in the theory class. The thing is, බලමු. හරි. You know, if you got any balance object, its clockwise moment of force equal to the anti-clockwise moment of force. In theory class, we already discussed. Okay, for this experiment, we need meter ruler. The meter ruler we use as a uniform rod. Meter ruler and knife edge mean this is it's very sharp edge, and 50-gram weight, a glass stopper or small stone in unknown weight, and string, very light string. Okay, they are the requirements. How we do in this practical? It is very simple. It's very simple practical. First get the sharp edge of edge like this, and balance the meter ruler on this edge. Balance the meter ruler like this. Meter ruler is uniform rod. Then you can balance the meter ruler. Now hanging the 50-gram mass, known mass, with x distance from the knife edge. Then Tantina method, place a knife edge on the stand and balance the meter ruler horizontally. That's the first step, right? As shown in the figure, known mass m naught and unknown mass m opposite side knife edge, and adjust the length y keeping length x at selected value until the rule balance horizontally. Measure the x and y values. මෙන්න මෙහෙම කරන් තියෙන්නේ, right? First මෙයා අපි හිතමු 5 cm කියලා. X value equal 5 cm, right? X value equal 5 cm. 20 cm කියමු. 20 cm. Then this unknown mass also, unknown mass mean we have to get approximately 50 එකක් ගන්න ඕනේ, 40 to 50 වගේ එකක්. I will explain what's the reason. That one also may exam question. Think it is weight 0. Think it is y, right? Y equal අපි මේක කරන්නේ by changing the distance from knife edge x20 and find the y this distance until balance. මේක balance එන්නේ කොතනදද? මම මේක හරිය මෙහෙම පෙන්නනවා. හරි මෙන්න බලන්න. This is a story. This. Okay, මේක නා practical එක කරලා බලන්න පුළුවන්. We can check this practical. Okay, this one. This is a practical. Okay, this is a meter ruler. This is the meter ruler, and this is a knife edge. Now, initially, the right side, the clockwise momentum was 0, anti-clockwise momentum was also 0. Okay, now I am going to select 10 kilogram one on left side. 7 meter length. 7 meter. අපි මෙතනින් පටන් ගමු. Let's start from this. 2 meter 2 centimeter කියලා හිතන්න. Then moment of force 196 on left side. Left side, the ruler is unbalanced now. Hari, I'm going to select 5 kilogram into right side. Put until balance. Until balance. Until balance එනකම් මෙයා දාගෙන යන්න. Balance එනකම් දාගෙන යන්න. Still not balance. Still not balance. Now balance. Balance. Now get the think this distance is x. Sorry. Meya x distance. Meya y distance. Right? X distance and y distance. Okay. I'm going to mark. Then අපි හිතමු මෙයා centimeter වලින්. It is 2 and 4. In first stage, x එක වුණා 2 centimeter. Y was 4 centimeter. Right? Now increase the මෙයා අපි දාමු මෙන්න මෙහෙට. Right? X distance increase up to 4 centimeter. Now මෙයා දාගෙන යන්න වෙනවා මෙහෙට. Until balance. Until balance. Until balance. Now balance. Now it is 8. එතකොට x 4 centimeter. Y should be 8 centimeter, right? Y should be 8 centimeter. Hari. I am බලමු. Put into 5 meter. 5 meter. It is 10. X equal 5 centimeter. Y equal 10 centimeter. Are you clear? Are you clear? Change in the x and balance the unknown mass. Then get x and y, the known mass distance and unknown mass distance as x and y measurements. Are you clear? Rehlan? Hi. Okay, අපි කරා. Hi. Now this value taken from the experiment, this value obtained from the experiment, I am going to mark on the Cartesian plane. Hari, me balan. The x distance was 2, 3, 4. The y distance was 4, 6, 8, double 4, 6, 8. Then you can get a graph. The graph is like this. This is a graph. This is a graph obtained by this experiment. This type graph. Okay, this type graph means what is the equation of this graph? Y equal mx no intercept. Y equal mx no intercept. The reason is the intercept equals 0. The y-axis cutting point 0. The y equal mx is the equation of this experiment. Y equal mx. Hari. What is our basic principle? You know. This principle, make a basic principle like a clockwise moment of force equal to the anti-clockwise moment of force. Right? Clockwise moment of force equal to the anti-clockwise moment of force. Hari. Then මොකද වෙන්නේ? Clockwise moment of force mean mgx. mgx නේ. හොඳට බලන්න. mgx. mg mean weight into x is the clockwise moment of force. mg mean known mass. Hari, the known mass. Make it m not mean unknown mass, then equal to anti-clockwise moment of force m naught g into y. It is anti-clockwise moment of force unknown mass into distance. Hari, unknown mass into distance. Hari, this is the most important thing. මෙතනින් පස්සේ ගොඩක් practicals වලට මේක ඕන වෙනවා. Hari. Then Okay, the graph is y equal mx no? Y equal mx no? This equation also we can prepare according to the y equal mx form. හරිද මේකත් හදමු y equal mx form එකට. කොහොමද එන්නේ? y equal mx. y equal mx. y equal mx form එකට හදන්න. Then now g to g cancel, right? G to g cancel because same g to g cancel. G to g cancel. Now y equal m naught, sorry, m over m naught. This is a gradient. This is a gradient equal x. Okay, this is my equation. Y equal m over m naught into x. M over m naught into x. M over m naught. M over m naught means the gradient of this equation. හරි. එතකොට අපිට gradient එක දන්නවා නම් if you know the gradient of this equation, we can get mass, it is equal to mass over unknown mass. Then we can find the unknown mass. අපිට unknown mass එක හොයන්න පුළුවන් කොහොමද? Unknown mass equal gradient. Gradient එක ගන්න පුළුවන් මොකෙන්ද? By this Cartesian plane. Y to y difference divide x difference. Y difference minus x difference. Then you can get gradient. Gradient multiplied by, then cross multiply කරාම gradient multiplied by m naught equal known mass. දන්න mass එක equal වෙනවා unknown mass එකට. The gradient into m into unknown mass, m into unknown mass, m into gradient into unknown mass. දැන් මෙතන g දාමු පැටලෙන නිසා g into unknown mass equal to the, sorry, g into known mass, m naught mean known mass, අපි දන්න mass එක equal to the unknown mass. Clear? Do I need to explain again? Okay, I will explain again. හරි මේක කතාව. Okay, මම මෙතන අඳින්න. Okay, now හරි මේ බලන්න. Now according to this graph, according to this data, we can draw a x and y axis. X and y axis, it is simple. It is x and this is y. අපි මේක mark කරාම the graph is like this. That means y equal mx plus c type graph. Not c type, y equal mx plus graph. Y equal mx plus graph because c intercept 0. හරිද? Very important. Therefore, now you already know this type. What's the basic principle? Clockwise moment of force. Clockwise moment of force equal to anti-clockwise moment of force. හරිද? දැන් අපි හිතමු the unknown mass is m naught. දැන් අරක මාරු වෙලා තියෙන එක වලට පැටලෙන්නේ. Unknown mass is m naught. Known mass is m. Known mass is m. Right? Now, what is our basic principle? M into mg into x equal m naught g into y. Now g to g same, therefore it's cancel out. 10 to 10 cancel out. Now to get this equation as මේක අපි ගන්න මේ y equal mx form එකට ගන්න to get this equation y equal mx form, then we have to get y equal both side divided by m naught, right? M over m naught into x. This is a gradient. මෙන්න මෙයා තමයි gradient එක. අපිට gradient එක හොයාගන්න පුළුවන්. We can find the gradient by graph, right? Y difference minus x difference. Y difference minus x difference. Hari. Now, if you got the gradient m over m naught, the unknown mass is m naught, right? Equal gradient. Hari. Gradient. Okay. Now, if you already know, then all the unknown gradient and known mass, then you can isolate the unknown mass. හොයාගන්න පුළුවන් unknown mass එක. The unknown mass by movement of clockwise and anti-clockwise movement of force method. Now, okay, Rela? Dehini? Fatima? Hari. Amina? Hari. Okay, let's move into next practical. Now, 10:30. We got 25 minutes for this practical. Okay, before fluid mechanism practicals, let's move into heat practicals. Heat එක ඉවර කරලිමු because fluid mechanism we have very small parts. Heat part is most important. Hari. Hari. It is first heat lesson practical. Okay, let's start. determine the specific heat capacity of unknown solid by mixed method. By mixed method. In a lesson. Okay, they are the materials required. We need calorimeter and boiling tube. And we need unknown substance. Lead should mean unknown substance, right? Lead should mean unknown substance, unknown material with and thermometer එකක් ඕනේ and water heater and tripod and Bunsen burner also there. Gas wire and triple beam balance and sufficient water and stir and thermometer again, right? I think you can remember the mixture method, right? If there is no heat loss, heat substance release heat equal to the cold substance absorb heat. Hari, hondata bala. Okay, the first step is Hari. මේ ටික හොඳට බලාගත්තොත් මේක very simple, right? The first step, get the mass of empty calorimeter mass. Measure the mass of empty calorimeter mass. Empty calorimeter mass. Think the empty calorimeter mass you mark as M1. Empty calorimeter mass you mark as M1. Right? Calorimeter kara measure kara. Right? That's the first step. Right? The second one, calorimeter filled with half of water. Water half fill karna. Measure karna the mass of calorimeter plus water. Calorimeter plus water, it is M2. Calorimeter filled with half of water and measure the mass. It is M2. Right? Then measure the temperature of this water and calorimeter system. Measure the temperature. Measure initial temperature. Measure initial temperature. Think it is theta 1. Initial temperature theta 1. Then, this is the empty calorimeter. It is M1. Filled up to this level water. It is M2. And measure the temperature using thermometer theta 1. Okay. Then, unknown heated lead shot. That means unknown heated. 100 Celsius heated. 100 Celsius heated unknown substance put into this water bath. Add into this water bath. And stirring wheel, using stirring wheel and observe the temperature change. Stirring and observe the temperature change. Temperature gradually, water temperature is increasing. Gradually, water temperature is increasing. Now think initial temperature 30, 20 then 30, 35, 40, 45, 50 increasing, right? Gradually increasing. 20, 25, 30, 35, 40, 42, 43, 44. Again, it's come to 43. That means maximum temperature here 44. 44 eකට right? ඊට කලින් you have to measure the mass of calorimeter plus water plus object mass. It is M3 and the final temperature of the mixture, final කියන්නේ මෙයාට අපි කියනවා final maximum temperature of mixture. Temperature temperature. Final maximum temperature of mixture, it is theta 2. Theta 2. Okay, this is a mixture method, right? This is a mixture method. And think specific heat capacity, see, specific heat capacity of water, it is CW, right? Capital CW. Specific heat capacity of calorimeter, C copper, because copper calorimeter used. Finally, specific heat capacity of lead shot, that means specific heat capacity of object, එයා ගන්න වෙන්නේ අපිට මොනවා හරි කියලා ගමු equation එකක් C OB කියලා ගමු. Okay, what is the target of this experiment? To calculate the COB. මෙයා හොයන එක තමයි වැඩි. C object එක හොයන එක තමයි වැඩි. හරි. Now you already know the mixture method. Mixture method mean according to the mixture method. I clear up to now this. Just I got simple experiment, mixture method experiment, and I got some values. I got some measurements. Right? Mewta measurements mam gatte. Hari making. Now you can show. Now you can get the specific heat capacity of unknown substance. අපි හිතන්න මේ වගේ substance එකක් තියෙනවා. We have unknown substance. Don't know the specific heat capacity. Specific heat capacity don't know. Then we can heat up to 100 Celsius and put into water bath and get this measurement. Using this method, we can get the specific heat capacity of this unknown substance. බලමු කොහොමද ගන්න. Okay, according to mixture method, now who is heated substance? Yeah, object release heat. Object means lead shot. Object release heat equal to the water plus calorimeter absorb heat. Water plus calorimeter absorb heat. Water plus calorimeter absorb heat. Right? Water plus calorimeter absorb heat. That's a mixture method. This is a simple mixture method. Then object release heat mean MC theta, right? No physical state change. Water absorb heat MCW theta, it is COB, plus calorimeter absorb heat MC copper theta. This is the equation. This equation very simple. Now what is the mass of object first? Previous experiment, what is the mass of object? What is the mass of object? What's the mass of object? Dehini. How to get the mass of object? Then මෙන්න මෙතන තියෙනවා M3 equal calorimeter water plus object. Calorimeter water plus object, and M2 is calorimeter plus water. Then if I subtract M3 minus M2, it is the object mass. Am I correct? Dehini? Understood? M3 minus M2, it is equal to the object mass. A bit clear? Tehlan? හරි. දැන් මම දානවා instead of mass of object equal m3 minus m2. That was a complete structured question as I think 2017. මම ඔක්කොම හවස කරමු in evening class. Okay, C object you don't know. මේක තමයි අපි හොයන්නේ. C object. COB into temperature difference. Temperature difference, how to get the temperature difference? Final maximum temperature T2. Object initial temperature 100. Then 100 minus T2. 100 minus T2. 100 minus T2 equal the next one mass of water. Mass of water කොහෙන්ද ගන්න වෙන්නේ? Water plus calorimeter M2. Only calorimeter M1. And then subtract. M2 minus M1. M2 minus M1. M2 minus M1 into water specific heat capacity, it is given CW into temperature difference of water. Water initially theta 1, finally theta 2. Theta 2 minus theta 1. Plus calorimeter mass of calorimeter M1, right? On the empty calorimeter M1 into C copper. Temperature difference also එයාගෙත් කීයද? theta 2 minus theta 1 because it is equal to water. මෙන්න this is a story. Now you can isolate C object of specific heat capacity. The object may specific heat capacity of unknown substance. C object, it is equal to කොහොමද දෙන්නේ? අර ටික මේකෙන් බෙදනවානේ. Yeah, M2 minus M1. That was exam question. මේක ඔක්කොම ලියන්න තිබ්බා. M2 minus M1 into CW theta 2 minus theta 1 plus M1 into C copper into theta 2 minus theta 1 divided by M3 minus M2 into 100 minus theta 2. Okay, this is the story. This is the specific heat capacity of unknown substance using mixture method. Are you clear? Don't worry about these symbols, right? Symbols from the experiment again. Right? Symbol I got from the experiment and just basic mixture method. The heated substance is heat equal to the water and calorimeter absorbed heat. MC theta equal MC theta plus MC. Are you clear? Hari? Kabir? Okay. Sharon? Okay, it is given in the tune. This is the store. But it is given in it with complex n. Yeah, M3 minus M2. C3 mean object specific heat capacity. Yeah, the same thing given. Okay, the method is given here. And the data experiment data given here. And these notes are very important. මේවා අහලා තියෙනවා. Take the calorimeter with its external covering to place where lead shot are being heated. It's not place heat insulated obstacle between water heater and the calorimeter. Yeah, that means this mixture method experiment correct for if it is no heat loss to the environment. If there is no heat loss to the environment, therefore we better to use calorimeter cover by thermal insulated layer, right? When a lead shot is being transferred to the calorimeter, care should be taken to prevent splash out water. We have to add it slowly, if not splash out water. එළියට විසි වෙන්න පුළුවන්. Water into in it and observe the thermometer reading very carefully. Yeah, thermometer reading we have to very carefully because it's increasing. Since lead is good conductor, the mixture reacts and maximum temperature very soon. Yes. This method can be used to determine the specific heat capacity of liquid by using the liquid in place of water and substance is non-specific heat capacity of solid substance. Yes. This experiment we can use to measure the specific heat capacity of liquid as well. The pilot experiment should be done to decide the amount of lead shot to be used to mix order to temperature of the mixture would be rise about 10 Celsius. That's the most important thing. Now, in this experiment, we think there is no heat loss to the surrounding. To ensure that no heat loss, to ensure that මෙන්න මේක කරන්න පුළුවන්. Method of compression can be used as a for the loss of heat. The initial temperature of the calorimeter with water is first cooled 5 Celsius. First initially cooling 5 Celsius before mixing the heated substance. The heated substance is then added to the water and mixed well. So the temperature of the mixture rise up to 5 Celsius. Then cool down 5 Celsius before adding, then add කරාට පස්සේ 5 Celsius increase වෙනවා. Then what happened? In the cooling process, absorb heat equal to the heating process release heat. Therefore, we can say there is no net heat loss. Heat loss එකක් නැහැ කියලා ගන්න පුළුවන්. The heat gained by the mixture during the 5 Celsius below the initial temperature is expected to component within the heat loss by mixture during 5 Celsius above the initial temperature. ඔන්න ඔය ටික කියව ගන්න. The notes very important. Okay, let's move into determine the specific meaning of type by mixture method. That one also always asking question. මේකත් නිතරම අහන්න. Always ask. That was clear 2018 exam question. It is 2018 most important. Determination of specific latent heat of fusion of ice by mixture method. First, for that one also we have to select calorimeter and measure the mass. Calorimeter and measure the mass as M1. Calorimeter and measure the mass as M1. Okay, it is M1. Right? And at half of water and measure the mass, it is M2. Aravidyama. Right? And measure the initial temperature, theta 1. Same as previous. Same as previous. Then the next point, we have to think this is a calorimeter with water now. This is a calorimeter with water now. Calorimeter means container. Thermal insulated container, right? Calorimeter with water, it is M2. M2, empty calorimeter, M1. Right. That next, I got the initial temperature of the calorimeter and water. It is theta 1. Now, the next step, we have to select medium level ice cubes. Medium level ice cubes. Medium level mean size again. Medium level ice cubes right? Medium level ice cubes at 0 Celsius. 0 Celsius mean the melting temperature. Melting point. Now, what we're doing now, that's most important thing. That one also better to avoid heat loss. We can increase temperature. Now we adding ice, then we can increase 5 Celsius and 5 Celsius temperature වැඩි කරලා adding ice up to decrease temperature by 5 Celsius. ඒ කියන්නේ අපි හිතමු theta 1 Celsius. Try to understand, right? That's most important one. Theta 1 is 20, right? Initial temperature 20. Cool the water and calorimeter up to 15 Celsius. 15 Celsius. Drop by 5 Celsius. And adding ice up to increase 25 Celsius. Right? Then we can avoid heat loss. Heat loss in heating process, release heat equal to the cooling process absorb heat. Right? But in this process, we have to increase temperature up to 25. Then we have 25 volt increase up to 25 Celsius. And adding ice up to 15 Celsius. 25 volt වැඩි කරලා initial temperature 20, adding ice up to 15 Celsius. Then we can say in the heating process, release heat equal to the cooling process absorb heat. Therefore, no net heat loss. I got Dihini? Sharon? Last part mean this part. This heating and cooling process. It is a මේක trick එකක් use කරන. හරිද? දැන් in mixed method if you need for easy calculation we have to think there is no heat loss. Heat loss එකක් නැහැ කියලා හිතන්න වෙනවා. Therefore if we get correct measurements we have to avoid heat loss. Heat loss or heat gain we have to avoid. Heat exchange with external environment. එතකොට අපි කරන්නේ මෙන්න මෙහෙම. Now think first we measure the initial temperature. First we measure initial temperature. Think it was 20 Celsius. 20 Celsius, right? 20 Celsius. Before adding ice, we can drop the temperature up to, increase temperature up to 25 Celsius. Then what happened? Some amount of heat released to the environment. Some amount of heat released to the environment. එතකොට heat එකක් release වෙනවා. We can't avoid. නතර කරන්න බෑ, release වෙනවා. හරිද? Now in the cooling process, cool up to normal 20 ne, cool up to 15 Celsius. 15 Celsius. Cool up to 15 Celsius. Then what happened? In the heating process, මෙතන 20 initial. In the heating process, release heat equal to the cooling process absorb heat. එතකොට මේකේ ඇත්තටම heat loss එකක් හරි absorb එකක් හරි තියෙනවා. No net heat loss or heat absorb. Now okay, then in increasing time release heat equal to the cooling time absorb heat. This is one trick I used to, not I, in this experiment used to avoid heat loss or absorb. Okay, කලින් එකේ කරන්නේ කොහොමද? In previous experiment, initial temperature 20. Initial temperature 20. Initial temperature 20 in previous one, right? ඒකෙදි add කරන්නේ heated one. Therefore, we have to drop up to 20 Celsius. 15 Celsius. Sorry. We have to drop temperature up to 15 Celsius and add lead shot and normal 20. Add lead shot and increase up to 25 Celsius. Then in the cooling process, absorb heat equal to the heating process release heat. Now, okay, Dihini? This is for previous one. කලින් එකේ. Yes, the same theory. That's a trick we can use to avoid heat damages, heat changes. Hari. Okay. Again, come to the mixture method. Fusion specific latent heat. What I did, first I got the empty calorimeter and measure the mass. It is M1. And add half of water and measure the mass M2. And increase temperature and avoid heat damages. Third step. Fourth step, select medium level ice pieces. And add into this. Carefully add. මෙතනදී spilt out වෙන්න පුළුවන්. We have to avoid spilt out and carefully add ice one by one into this water. Ice one by one into this water. And මෙතනදී අපි use කරන්න ඕන, we have to use a net stir. What's the purpose of adding net stir? This ice cube dissolve මෙන්න ice cube තියෙන dissolve without environment involvement, without atmosphere heat involvement. That's why we use totally submerged ice by net stir. Net stir එකක් අපි use කරනවා. මේ වගේ net stir එක. This is a shape of net stir. Net stir කියන්නේ දැල් වලින් හදපු stir එකක් මේ වගේ. Right? It is net stir. Net stir. net style එකක් use කරලා තියෙනවා, right? Net style, using net style, dissolve ice inside the water, fully submerge into the water, right? Now when it is reached to our required temperature, we can get the final temperature of mixture, right? This is final minimum temperature, right? Minimum final temperature අපි අර විදියට ගත්තා නම් මෙතන 20 heat up to 25 Celsius, the final temperature 15 Celsius. 15 Celsius, it is minimum final temperature, right? Right, this example 15 temperature. Okay, that is the most important one. Get the mass of water after dissolving ice and finally calorimeter. Method calorimeter, water plus ice. It is M3 now. M3. Then specific heat capacity of water CW, specific heat capacity of calorimeter C LO something, specific latent heat of fusion of ice L තමයි හොයන්න ඕනේ. හරි, මේ තියෙන්නේ කතාව. හරි, I will show you what are the data requirement again. Okay, first one, empty calorimeter. It is M1. Then calorimeter plus water mass, it is M2. Andra bala, it is initial temperature theta 1. Initial temperature theta 1. Then final minimum temperature, that's the most important word. It is minimum, right? Minimum, because adding ice, no? In previous one, maximum temperature. Minimum temperature, it is theta 2. Then get the water plus calorimeter, ice දැම්මට පස්සේ මේ, right? Calorimeter plus ice dissolved වුණාට පස්සේ it's M3. Then specific heat capacity of water CW, specific heat capacity of calorimeter C කොපම දාමු අපි, specific latent heat of ice, it is L. Hari. Okay, this is a basic data collection of the experiment. Hari marvelous. The thing is, you have to remember, we have to avoid heat damages and මේකදී අපි use කරන්න ඕනේ මේ medium level ice. මේවා තමයි points you have to remember. Avoid heat damages, avoid heat loss. මේවා අනිවාර්යෙන් මතක තියෙන්න ඕනේ. Avoid heat loss. And what else? Medium level ice දාන්න ඕනේ. Medium level ice දාන්න ඕනේ. ඇයි කියලාත් exam එකේ ඇහුවා. What's the purpose of adding medium level ice cubes? If you use very large ice cube, it takes more time to melting, right? It's take more time to melting. If you got very tiny ice particles, what happen? It's before adding, they will be melting due to the atmospheric heat, right? That's the most important thing. Medium level ice cubes are done and dissolve with stir with net stir. Use net stir is very important. Use net stir. What's the purpose? To avoid heat coming from atmosphere. Then up make a ස්ථය කරද්දී we have to submerge fully in water. Fully submerge in water. And the next thing, the most important thing, මේකත් මතක තියෙන්න ඕනේ. Before adding ice up, other thing we have to very slowly add ice cube. Slowly add ice cube. Why? If not spilled out water. If not spilled out water. තව එකක් තියෙනවා. The most important one. Before adding ice cube, we have to wipe by tissue papers. ඒ කියන්නේ ඒකේ තියෙන the surface water wipe by tissue paper. Tissue. Why? It's contain already melted water on the surface. Even දැම්මොත් the experiment will be coming errors, the mass, melted mass. Okay, completely melted on කොහෙදද? Within the water due to the absorption of heat from the water. Okay, therefore before adding we have to wipe out by tissue papers each ice cube. Okay, are you clear experiment? Habib, any doubt of any not? You are getting doubt? Okay, you have to carefully remember this all factors and experiment data. Fatima, clear? Habib, any doubt up to now? Dihini? Understood? Please remember these green color points. They are very important. Now, this is the mixture method. Substitute into mixture method. Mixture method එකට දාන්න තියෙන්නේ. Okay, according to mixture method, water and calorimeter release heat. Water plus calorimeter release heat equal to ice absorb heat. Ice absorb heat. Ice absorb heat. හොඳට බලන්න. Water and calorimeter release heat mean mc theta, no physical state change, mc theta equal ice absorb heat only ml. Ice absorb heat only ml. Right? Now, the mass of water. Happy water mass එක ගමු. Mass of water m2 minus m1. Any doubt, please ask me. M2 minus M1. Water specific heat capacity CW. Temperature difference, initial theta 1. Theta 2 minus theta 1. plus mass of calorimeter M1, empty calorimeter M1, C copper, temperature difference same as water, theta 2 minus theta 1, equal to mass of ice M3 minus M1, right? Sorry, M3 minus M2. May I do M3 minus M2 into L. Into L. Okay, what is our target? To get the L, and isolate the L. Isolate the L. M2 minus M1 into CW, theta 2 minus theta 1 plus M1 into C copper, theta 2 minus theta 1 divided by M3 minus M2. It is added MC theta for water as well. Sorry. මේකට අපිට water වලට MC theta දාන්නත් පුළුවන්. MC theta plus water. MC theta plus MA. Yeah, that's the best way because ice at not perfectly zero. Yeah. මෙතන දාන්න වෙන අපිට MC theta. Sorry. Then mass of ice M3 minus M2, specific heat capacity of water CW minus theta mean theta 2, final temperature theta 2 minus 0. Theta 2 minus 0. Yeah, that's mean after melting, it's come to theta 2 Celsius. Theta 2 Celsius. Okay, therefore it is theta 2 minus 0. It is 0, right? Theta 2 minus 0. Plus ML. M plus M3 minus M2. L. Our target is get the L. Then this part make a subtract window. Don't get is very complex. It's very simple. Just mixed method equation I substitute, right? Array data දානක විතරයි වෙනස්. M3, okay. This is water absorb heat, calorimeter absorb heat. මේ part එක මෙහෙට ගන්න වෙනවා. Subtract M3 minus M2 CW theta 2 minus 0 mean theta 2 theta 2 divide by M3 minus M2, right? This is the final equation. Don't take it very complex, right? Very simple thing. I did only substitute into common equation. This is a water absorb heat plus calorimeter absorb heat equal to ice absorb heat. Ice absorb heat ml plus mc theta. ml for melting. Melted water 0 Celsius. 0 Celsius water come to theta 2 Celsius. Then it is mc theta. Okay, clear Dihini? Okay, let's move into final heat practical. May you get the notes me noted mean me notes make it. I already explained all notes. You can read. You can read. Hurry. Determine the specific latent heat of vaporization using mixture method. Using mixture method. Hurry. Okay, this one also very simple, same as previous method, but the thing is, the main difference is we need steam generator because we need steam for vaporization. Hurry. Okay. Okay. Hurry. This is the most important practical. Most probably this practical will be your exam practical question. Making a okay, this one also same, but the only difference is it is vaporization. The specific latent heat of vaporization. Making gun. Give me a second. Okay, we have only 2 more practicals. දෙකයි තව තියෙන්නේ. ඉවර කරන්න පුළුවන්. හරි. Okay. First thing, we need a steam generator. Steam generator. This is a steam generator. Steam generator for generate steam, and we need tripod and Bunsen burn. Tripod and Bunsen burn. Hurry. And we need thermometer for this steam generator to get the temperature. And there is a tube here that we call pressure control tube. Pressure control tube. You can draw this diagram, pressure control tube. Pressure control tube. If it is increase the pressure more than expected level, more than safe level, what happen? The water will be spill out. Water will be spill out due to pressure difference. Okay. Now this generated steam flow into this steam carrying line, steam transfer line, and it is entered to steam trapper. What's the meaning of trapper? It's collector, right? Trapper. Steam trapper is a special one. It is this is the shape of steam trapper. Steam trapper is box like this. It's a box like this. Box this is a steam supply tube. Steam supply, right? This is steam supply. Clearly understand, this is steam supply, right? And there is a tube like this. There is a tube like this. tube එකකින් තමයි steam flow into the downward this type shape tube. Then what happened? The condensed water in the transportation process, condensed water, what happened? It is collecting, and only vapors make condensed water collect, and vapor is transferred to the calorimeter. Only vapor transfer to the calorimeter. That's the purpose of steam trapper. Steam trapper. Steam trapper. Right? Steam trapper. Only vapor is transferred to the calorimeter, provided to the calorimeter without condensed water. Without condensed water. During the transportation, during cooling from atmosphere, some part of water vapor will be condense and convert water. If it is condensed water add to the calorimeter, it is problem to our experiment, right? It's coming errors. Due to that, it's coming errors. The errors, therefore we have to use steam trapper. And this is a calorimeter. It's calorimeter. This line is very close to calorimeter water surface, and we can get the thermometer is there, and calorimeter without, and stir is there. No need net stir, simple normal stir. They are the equipment and experiment setup. The most important thing is steam trapper. Steam trapper purpose is collect condensed water and only provide steam into the calorimeter. Steam into the calorimeter. Then මොකද කරන්නේ? Same as previous. Measure the empty calorimeter. Empty calorimeter. M1. Empty calorimeter. M1. Right, empty calorimeter M1. Is it lagging? The video lagging, right? Yeah, wait. Okay, now. Okay, first get the empty calorimeter. Empty calorimeter M1. Then calorimeter plus water. Calorimeter plus water M2. Same as previous. Kaliන් විදියම තමයි. M2. M2. Then initial temperature. Initial temperature theta 1. Water and calorimeter initial temperature. Right? Using thermometer we can measure. ඊට පස්සේ then measure calorimeter. Sorry. Then provide ඊට පස්සෙත් අපි කරන්නේ think initial temperature 20. That's the most important thing. Initial temperature 20. Right? Then drop the temperature up to 20. Drop the temperature up to 15 Celsius to avoid thermal damage. And supply vapor up to 25 Celsius. Increase up to 25 Celsius. Then the heat in the cooling process absorb heat equal to heating process release heat. Right? අර විදියම තමයි. Same story continues. Okay, then provide this steam generator produce steam, provides to the calorimeter, and this calorimeter provide this steam trapper provide vapor carrying tube tube it should very close to the water layer. Then if not, what happen? Some part of water vapors wasting. It is released to the atmosphere. Therefore, very close. It should very close to the water surface. Water surface. And what's the purpose of this asbestos sheet or thermal insulated sheet? If not this what may steam generator heat transfer to the calorimeter, it's coming measurement errors, right? Temperature errors, temperature changes. Therefore, we have to use asbestos or whatever thermal insulated sheet for thermal insulated sheet for protect normal temperature in other side. Right? Thermal insulated sheet is compulsory. Hari. Onna vidhe tama karana. Hari. Then after supplied steam, we can get the final temperature. Final temperature of the mixture. Final temperature theta 2. Final temperature, it is final maximum temperature, sorry. Final maximum temperature because temperature increasing, final maximum temperature. Then we can get calorimeter, water plus, water plus vapor. After vapor enter the calorimeter, it is empty. Right? Then specific heat capacity of water CW, specific heat capacity of calorimeter C copper, specific heat capacity of yes, that's all required data. Then let's move into the mixture method. Okay, this experiment also we have to avoid thermal damages, and we have to use a steam trapper to avoid enter condensed water into calorimeter, pre-condensed water into calorimeter. And this vapor supply tube must very close to the water surface. What else? And we have to avoid thermal damage and drop temperature 5 Celsius and increase by 5 Celsius in the heat supply, vapor supply. Very carefully we have to maintain, right? We have to maintain. Additionally, we have to use steam generator and calorimeter. We have to separate by thermal insulated layer. Insulated layer. Okay, what to do? Now get Q equal, not Q equal. Then one of the heat release, vapor release heat equal to the water and calorimeter absorb heat. Water and calorimeter absorb heat. Water and calorimeter absorb heat. Vapor release heat MC theta, ML plus MC theta, no? mc theta equal mc theta plus mc theta. Vapor release heat. Vapor release heat. Vapor release heat. Vapor release heat mean vapor mass. Mass of vapor m3 minus m2. කලින් වගේම. It is same as previous. m3 minus m2. m3 minus m2. m3 minus m2. L don't know. Plus mass of vapor m3 minus m2. Specific heat capacity of water. Now it is already condensed. It is water. Theta mean temperature difference of vapor. Here the වෙන්නේ. It's 100 to theta 2. 100 minus theta 2. Condensed the 100 Celsius water. 100 Celsius water convert to theta 2 Celsius. 100 minus theta 2. Hari. The mass of water m2 minus m1. m2 minus m1. m2 minus m1. Specific heat capacity of water Cw. Cw. Temperature difference of water theta 2 minus theta 1. Final temperature minus initial temperature. Plus mass of calorimeter M1, empty calorimeter, specific heat capacity copper, C copper, into temperature difference same as water. Theta 2 minus theta 1. Now you can isolate it. L equal m3 minus m1 Cw theta 2 minus theta 1 plus m2 into m1 into C copper theta 2 minus theta 1 subtract මේ part එක මෙහෙට ගන්න වෙනවා m3 minus m2 Cw 100 minus theta 2 divide by m2 minus m3 minus m2. This is the final practical. This is final practical. මේවා මේ විදිහටම අහලා තියෙනවා. They are exam questions. All practicals, all heat lesson. I explained three practicals. All practicals was asking in the past paper questions. Okay, let's do all past paper questions and all practical past paper questions in evening class. Okay, now today we discuss 6 practicals. 6 practicals completed, heat lesson 3 practicals and measurement. No, we discussed 7 practicals. Heat lesson 3 practicals and force lesson 2 practicals and measurement lesson 2 practicals. 7 practicals completed. We have only 2 practicals remain. Okay, let's start. Let's do it evening. No, now you are tired. No? Okay, let's do evening. Fluid mechanism and mechanical properties practical and practical based questions. Questions टिक ඔක්කොම අපි කරනවා 2015 to all practical question we discussed in evening class. Okay, today evening class very important. And we have very limited time. We have only 2 weeks. We can continue our class. After that, you have to start your first. You have to start to ready for your first subject. First subject BST, no ET and BST. 12th of August. Hi. Then let's do evening. 2 remain practicals and ICT practicals and practical based questions. Okay, how about today's session? I got something new. Okay, then let's meet in evening class. Goodbye.